Coders, so welcome to my video. In this video, we'll see how to use dup and dup2 flavor of you know duplicating and redirecting of the file descriptors. So these APIs or system calls is being used very prominently underneath in our shell commands. Okay, so by using these APIs, we can redirect the file descriptor that is used for input output or the error streams into files. Okay, so this system calls is being used to redirect the logs from output stream to some file, or we need some selective logging. In that case, we use these APIs. Okay, so what's else in these APIs? Let's have a look. So these two APIs are used for duplicating and redirecting of the file descriptor. Okay, so this file descriptors that is being duplicated is just like a pointer to the same memory. It won't create a new file. It is the pointer that is addressing the same address location uh, for the FD that is given to it. Okay, so this is the API dup, and we are giving some FD or the file descriptor uh, as an input to this loop, and in return of this loop will get a new FD that will point exactly the same location where the old FD is pointing. Okay, so it's create a copy of the file descriptor using the lower number unused file descriptor. So as we know, we have majorly the three main file descriptor that is being constant throughout the programs, that is 0, 1, and 2. And 0 is std in, 1 is std out, and 2 is std in. So these are generic file descriptors that we use. For example, we are using printf to print something on the terminal. In that case, we use the one file descriptor. So let's take an example of dup so that this thing will be clear. Okay, so I will define fd dup is equal to, I'll create and open a file. I'll create a new file. Okay, so here we have dup underscore output dot txt. Okay, so what I do here, I'll make it right only. Then I will take o underscore create a new file. Then we'll truncate. Okay, I'll give the permissions to this. Okay, so here I get a FD. Okay, the file descriptor that is pointing to this file. It will create the file and point to that location. Okay, so I'll take an error case as well. If fd underscore dupe is less than 0, then we have an error. Okay, so I will take an error over here. So I will take PERROR. I will problem in open file. Okay, like this. And then I'll exit. I'll take this one only. Okay. So after this, what I have to do, I have to duplicate this file descriptor so that we have a new file descriptor that will point to the same output file. So we'll have two file descriptor and we will write to those two file descriptor into this file and see what happens. Okay. So I will take integer copy of that FD. Copy FD is equal to, I'll take that group, and inside this parenthesis we have fd underscore dupe. Okay, so it will create a copy fd. Okay, so here also if we want, we can have an error condition. Same here. Okay, so here we have copy fd. If it is less than 0, then we should have an error, error, or and here we have error in dupe. Okay, and here also I exit. Okay, now the next thing is I will write to both the FDs, this FD dupe and this copy FD, to this file only. Okay, and we'll see whether this will work or not. So for file descriptor, I use the printf flavor of dprintf, in which the input is a file descriptor. So the first file descriptor is fd underscore dupe, and I will write something. Okay, so writing from fd underscore dupe descriptor. Okay, so like this, and the second line I'll do is copy underscore fd. So we have copy underscore fd, that is a second descriptor, and in which I will write copy underscore fd. Okay, so I quickly compile this, copy fd, and redirect dot c. Here I have copy fd cat. We have group. Okay. So here what I see, I got both these descriptors output, writing from fd dupe and writing from copy. So the same, you know, target is same, but the pointers are different where we are writing. Okay. So this is the first use case where we are using dupe. Okay. So if we want to take this copy of the output, so I will take here, I'll print here rather. Okay. So printf, here we have copy fd is equal to percentage d, and here I have copy fd. Sorry. So I'll print this as well. It should be 3 mostly. So I have fd underscore dupe. So here also fd underscore dupe. I'll taking next line. Here also next line. Save it again. Okay, so 3 and 4. So 0, 1, 2 is reserved for input, output, and the error streams, but this FD, this is 3 and this is 4. So sequential, this is taking. Okay, so the first point which we mentioned here is creates a copy of this using the lowest number of unused file descriptor. Okay, so 0, 1, 2 is fixed, 3 is opening the file, and we are left with 4. So it's a sequential order which we are taking like this. Okay, so there is one more form of uh, this loop, that is loop 2. So what is the difference between two? Let's have a look. I've seen some example, like we have list ls, and here we have a redirect operator, and we are putting in some file like output.txt. So when we open this file, we'll have the list of this directory into this file. So what is this redirect operator? So this we want to clone. So underneath it is using dup2, but we will execute this command using our program dup2. Okay. So I'll open our code again. So what I will do, I will remove everything from here. So as I need to redirect our ls output to a file, so we need a file first. Okay, so I will take a new file, fd, open, same way. Okay, so I will give the name as ls output. Okay, .txt. So this is the name of the file where we are storing the value of ls. Okay, then we have same o underscore write only, then o underscore create. We are creating a new file, then o underscore trunk, and then we'll give the permission 0644, something like this. And let's print it as well. I think better we'll print it. The fd is equal to percentage d, and here I will do that d. Okay, so we open the file. So our thing is ls redirecting to a particular file. So we need ls command as well, right? So for that, what I will do, first I use dup2 here. Okay, so in dup2, what I will do, I will take this fd of this file that is created, and now stdout, this is file number. Okay, so what I am doing here, I am taking this fd, and this is not other than one number. Okay, so the default stdout fd is one. So we are imposing this fd to this, so that this one number fd, the output stream of this program, will goes to this fd only. So these two will redirect to the same output file. Okay, so whatever we write on the printf or stdout, it will go into this file directly. Okay, so what I will do after this, I will take execlp, then we have ls command, comma ls. If you don't know about this execlp command, it will override our program with output of this. Okay, and it will redirect the output to this file, as these two fds are now same. Okay, so the standard output will be redirecting to this file. So whatever output we are getting from this ls, by hijacking this program, that will goes into this text file. So let's do this compilation and see whether, sorry, so gcc, I'll take like this, and now we have a dot out. Okay, so fd is 3, cat ls output, and if I go for ls, okay, is the same output. It's very useful. So any question you have, you just comment in the down below. Okay, so let's see in the next video. Thanks.